Okay, now we are going to talk about the introduction for Maglev train. Imagine a train without wheels. Instead of rolling along the track, it floats quietly and glides smoothly from the point of origin to point of destination without touching the rail. This may sound like a science fiction, but instead this technology has already exists in several places. This is known as Maglev train, which is also known as magnetic levitation. This futuristic locomotive has so much to offer in traveling industry, such as being potential to be more faster, more safer, and more energy efficient than commercial transportation system. Although these trends are few, but this is a hot topic in terms of research among electrical engineering community. As a result, maglev could be the mode of transport sooner than we think. Now we will look into the history of maglev. So the fundamental ideas behind maglev technology can be traced back to the early 20th century. Few scientists, namely Robert Goddard and Emily Blackett, even dared to propose a vehicle that would float using magnets. In 1934, a German named Hermann Kemper was given the patent for the first concept of magnetic levitation train. In 1960s, the idea really began to manifest, and at this time, German and also Japan has begun their research for the potential of maglev. German has built and tested their prototype design named Transrapid, which has achieved over 250 miles per hour or 402 km per hour. Japan has also tested two series of their own design, which is called ML500 and MLU, and which exceeds over 300 miles per hour, which is almost 483 km per hour. Japan continued to develop their maglev technology in the 90s and also beyond. The new series, which is called as MLX, has broke 350 miles per hour, which is 563 km per hour in 2003. In Germany, the Transrapid is converted to a commercial connecting line from Berlin to Hamburg, which was proposed in 1992 but was rejected by the government in the year 2000. The Chinese government has took notice and commissioned the German to build the Transrapid train in Shanghai. Now the Shanghai maglev resulted from the venture is the only high-speed maglev in the commercial use, which carries the passenger at a distance of 19 miles, which is 30 km in just 8 minutes, reaching the top speed of 250 miles per hour, which is 431 km per hour.
The car is suspended above the track by superconductors. These magnets work like typical magnets when their poles face one another. They interact with basic metal loops embedded in the maglev guideway's concrete walls, make the loop conductive like aluminum so they can move when a magnetic field passes by. Those in the guideway do three things. One, lift the train 5 inches above the guideway, another keep it stable horizontally. Magnetic repulsion forces the train car away from the center or towards the bottom. Both loops keep the train car in place. The third set of loops is alternating current propulsion system. The railway vehicle is guided along the guideway using the magnetic attraction and repulsion. The front corners feature are north-facing magnets, whereas the back corners have a south-facing magnets.
And here I'm explaining how maglev train work. So we can see in this deviation, the train above have the magnet, and same with the rail, the pole of magnet I mean. And then like to make it move, they have a propulsion beside of the rail. They have same poles of magnet to make it move. As fast as the magnetic pole switching, it means more speed of the train. And what of all of the material use a superconductor magnetic. And lastly, to make the train stop, so we just a little bit slow the the magnetic things, so and then the train will be stopped.
The advantages of maglev. First, a maglev train is far faster than a conventional bullet train. Maglev can reach speeds up to 500 km per hour. Second, since the linear induction motor prevents trains from moving in opposite direction, an accident involving two maglev trains is almost impossible. Third advantage is the maglev train is a slightly elevated mode of transportation. Fourth, maglev train utilize 30% less energy than conventional trains. Fifth, grade of climbing and maneuverability. Furthermore, maglev train can make tighter turns than conventional rail trains. And lastly is maglev trains are quieter than regular trains, which is it does not produce any rolling, whirring, or engine noise.
As conclusion, we have all been amazed by the wonders maglev did achieve and could achieve in the future. A train that can magnetically levitate has no contact with the rails, which reduce the friction and resistance, allows it to travel much more far in a faster speed. Maglev has amazing features such as superconductors, which allows it to hover above the track. Magnets in the concrete wall allows the train to hover in the center and also move forward and backwards using attraction and repulsion theory. As we all know, there are few advantages that have been discussed, which is maglev is much more faster than conventional train. Maglev uses 30% less energy, and also maglev is much more quieter than other conventional train. With this, it seems that maglev is the only way to the future. Thank you, and that's all from us.